Welcome viewers. In this video we'll see the static characteristics of stepper motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Static characteristics stepper motor. What is static characteristics? The characteristics related to the motor which are stationary are called static characteristics. Not running condition. During running condition, the characteristics known as dynamic characteristics. Under not running state is called a static. Stationary. Under stationary condition is called a static characteristics. So in this video, we will see in the static characteristics under stationary, not running. So the first one is the torque versus step angle characteristics. T theta characteristics. Now we'll see the graph. So in the x-axis we have the step angle theta. In y-axis we have the torque. Torque is available. See this in the graph is keep on when the step angle increases, the torque is keep on increases and reaches this maximum value. It's called a holding torque. We'll see what is holding torque. As correspondingly it's called a static torque Newton meter. After that this torque is keep on decreases, again reaches zero value. 0 to maximum to 0. At this point it is called a holding torque. The corresponding step angle is theta m. So the stepping motor is kept stationary at rest position by supplying a current in a specified mode of excitation. So it is kept in stationary mode. If an external torque is applied to the shaft, an angular displacement will occur. So while applying the external torque, there is a angular displacement is occurs. So and the next point is the relation between the external torque and displacement angle may be plotted as T theta curve. So while applying the external torque, there is an angular displacement occurs. So we are drawing the graph between torque and step angle. The maximum of static torque is called a holding torque. So we discuss in the diagram at the maximum point is called a holding torque, at which the theta is theta m. So after theta m, the motor move to the next equilibrium position. The holding torque is defined as the maximum static torque that can be applied to the shaft of an excited motor without causing continuous rotation. So this holding torque is nothing but maximum static torque that can be applied to the shaft without causing continuous rotation. There is no rotation. So after this holding torque, maybe it will start rotate, right? So the maximum value of the torque at that is not rotating. Now we'll go to the next characteristics, torque versus current. So this torque versus current. In x-axis the current is available, y-axis holding torque is there, right? So this is a 0 position. The two curve available. This curve refers the variable reluctance motor. Torque versus current characteristics of variable reluctance stepper motor. And this curve refers permanent magnet stepper motor or hybrid stepper motor. See this curve is started 0 value, 0 current because of variable reluctance stepper motor. So variable reluctance stepper motor is torque is 0. But in case of permanent magnet or hybrid, because of permanent magnet always some torque will be available. That is called redundant torque because of permanent magnet. Here is a electromagnet. So this portion is nothing but a redundant torque. Thereafter it keep on increases gradually, then rapidly it increases. This also variable reluctance motor gradually increases, thereby increasing rapidly, right? So the important point is variable reluctance motor have 0 torque, but this permanent magnet hybrid having some redundant torque. So it is not start at 0, it start with some value. Now we'll see what are the parameters available. The holding torque increases with the current, and the curve drawn between holding torque and the current is called TI characteristics curve. So this what the diagram we discuss is the graph drawn between holding torque and current. For variable reluctance stepper motor, this curve starts from 0 point, right? But for permanent magnet and hybrid stepper motor, the curve starts slightly rises in the holding torque. So this is due to presence of dedentant torque due to the permanent magnet in the rotor when current is 0. So in this permanent magnet and hybrid stepper motor, because of the permanent magnet, there is some torque available in the even the current is 0, but it is not available in the variable reluctance stepper motor. So these two curves we already discussed in the diagram. Now we'll see what is meant by holding torque and what is dedentant or cogging torque. So holding torque is we already discussed. It is defined as the maximum static torque that can be applied to the shaft of an exciting motor without causing continuous rotation. So earlier also we discussed the same point. So maximum torque that can be applied without continuous rotation. Dident and cogging torque, it is defined as the maximum load torque that can be applied to the shaft of an unexcited motor without causing continuous rotation. Unexcited. Without excitation condition, some torque is available without causing continuous rotation. Rotation also not available. In both the cases, without causing continuous rotation, because we are discussing static characteristics, not a running characteristics, right? So in this video, we discuss about the static characteristics of a stepper motor. There are two characteristics, that is torque, this holding torque versus step angle. In that we have the torque keep on increases and reaches the maximum value at that point called a holding torque. Holding torque is the maximum torque that can be applied without causing continuous rotation. The second characteristic is holding torque versus current. That is discussed for three different motors: variable reluctance stepper motor, permanent magnet stepper motor, and hybrid stepper motor. In case of variable reluctance stepper motor, there is an electromagnet, so the torque is 0 at the 0 current. It starts with 0. That is an important point. But in case of permanent magnet or hybrid is nothing but combination of both permanent magnet and variable reluctance. So there also permanent magnet is available. So due to this permanent magnet, what we have, some dedentant torque is available even when the current is 0. That is the important point we observe in the torque versus current curve. So two important parameter is holding torque and dedentant torque. Holding torque is maximum static torque without causing continuous rotation. Dedentant torque also maximum torque under unexcited condition. So subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Thank you for watching. All the best for your examination.